Aloha, everybody. This is Gigi from Kauai Community College. This is a video of fraction review. And in this one, we are going to be multiplying fractions, including mixed numbers. And when I say multiplying fractions, I mean to do this visually so that we can justify the process and not just telling students to go ahead and multiply straight across, which is not what I am doing. Okay, so here we go. We are multiplying, first of all, a fraction to a whole number. So 3/4 times 2, and as we know, in terms of multiplication, that means two groups of 3/4, right? So here is one group of 3/4, two groups of 3/4, and we can see that that is one full if I take that one part and move it up. And then I will also have a half, or would be 2/4, right? So however you think about that, you could say that is one full and two quarter, or you could say that is the same as 1.5. So that is how we think of multiplication of fraction and whole numbers. Just repeatedly how many of those copies that you have, right? That is in line with multiplication of whole numbers that we have learned before. Okay, now fraction by a fraction, 3/4 of 2/5, or we can think of it as 2/5 of 3/4. And so I'm gonna show you two different ways, bar model and an area model. So for bar model, I'm gonna go ahead and start with 3/4. So now I'm thinking I'm gonna take 2/5 of that 3/4. And to take 2/5 of something, I have to divide that thing into 5 equal parts and then take 2 equal parts out of the 5, right? That's what 2/5 of something means. So I am going to take my chopping thing and chop those little pieces into 5 equal parts. Okay, so I'm going to chop them into 5 equal parts each. So can you visualize that? How many little pieces do I have if I chop each one of those equal parts into 5? And we see that would be 15. Right? I mean 15 out of 20, right? So now my one has 20 equal parts. So and the fraction that I have is 15 of those. And when I say 15 of those, 15 of what? 15 of 1/20, right? So that would be my fraction size. Okay, now I am going to take 2 out of the 5, right? So 2 pieces out of my 5. Okay, then I'm gonna take 2 pieces out of my 5, right? That what it means to take 2/5 of something. And then I'm gonna take 2 pieces out of the 5 that I have, right? So all together, the red shaded part is my 2/5 of 2/5 of 3/4. And 2/5 of 3/4 is 1, 2, 3, 4, 5, 6 pieces. And that would be 6 pieces. And what is the size of those pieces? That's the 20th, right? The 1/20 size. So that is 6/20. Okay. And we can reduce that if we want and think of it as 10th. And so that would be like 3/10. Okay, but that's not necessary, I guess. I mean, unless you really want a simplified fraction. But the concept is taking 2/5 of something means to take that, whatever we got, and chop it into 5 equal parts and take 2. Okay, now we're going to think about this as an area model. Okay, so an area model, we're going to go ahead and start with 3/4. So here I'm going to go ahead and divide this into quarters. 1 equal part, 2 equal parts, 3 equal parts. Oops. There you go. 4 equal parts. And I am shading this. So there you go. That is 3, right? 3 out of 4. That's 3/4. Okay. And what I need to do next is I need to go ahead and divide the what we have into 5 equal parts and take 2, right? In the bar model, I go vertically. In the area model, I'm going to go horizontally. So 1, 2, 3, a little bit bigger. So that would be 1 equal part, 2 equal parts, 3 equal parts, and 4 and 5 equal parts. Right, so I have here 5 equal parts. And what am I doing? Taking 2 out of the 5. So 2 out of the 5. So that would be the top. I'm going to go ahead and take the top 2. So that would be these right here. And I only take from what I have, which is just those parts there, not the empty, because that's not what I have, right? I'm taking 2/5 of 3/4. So our solution is right here and right here. Here is our solution. So I'm going to use a different color pen here. How about black? This one right here is my answer. That one right there is 2/5 of 3/4. The question is, what fraction is that? How do we represent that fraction? Well, 1 is the whole rectangle. The whole rectangle is a 4 by 5. A 4 by 5 is 4 groups of 5 equal parts. So that would be 20, right? So my denominator is 20. My denominator is 20. And my numerator is a 2 by 3. And that is 6 equal parts out of 20. Same answer, but just look a little bit differently, right? So our job as a teacher is to know all different ways to represent things so that we can catch the majority of our students, if not all of them, right? So that is multiplication with bar model and area model. Now, we're going to go ahead and extend this multiplication with fractions larger than 1, or we say mixed numbers. For example, 2 and 3/5 multiplied by 4 and 2/3, right? Do you remember the area model when you would multiply 125 times 34, right? We do this and then we break them down in terms of place value. 200 plus 20 plus 5 multiplied by 30 plus 4. The same concept applies here. Okay, so we are going to go ahead and put up our rectangle. 2 and 3/5 means 2 plus 3/5, 2 whole plus 3/5. And 4 and 2/3 would be 4 whole number plus 2/3 as a fractional part. And then we're going to say, well, 2 groups of 4 is 8, right? And then 2 groups of 2/3, 2 groups of 2 is 4, so 2 groups of 2/3 is, you are right, 4/3. Okay, now let's think straight down vertically. 4 groups of 3/5, 4 groups of 3, right? 4 sets of 3 is 12. 3 what in this case? 3/5. So 4 groups of 3/5 is 12/5. And then 2/3 of 3/5. So we're thinking 2/3 of 3/5. Okay, so now I'm going to think 1/3 of 3/5. What is 1/3 of 3/5? 1/3 of 3 is 1. 1 what? 1/5. So then 2/3 of 3/5 is just double of that, which is 2/5. And that's how I would think in my head, right? Now, if you couldn't do that in your head, then we would have to draw 3/5 and then take 1/3 of it. Okay, so 3/5, 1, 2, 3, 4, 5, right? So 3/5 is this right here. And we are taking 1/3 of 3/5, or we're taking 2/3 of 3/5, 1/3, 2/3 of 3/5, and that is 2/5. Okay. Now our job is to go ahead and combine all of those small areas to get the area of the big rectangle. So we say 12/5 is the same as 5/5, another 5/5, and a 2/5, right? So this is 1, 1, and 2/5. So this is 2 and 2/5. This is the same as 3/3 plus 1 more third. So that is 1 whole and a third. So we would say 8 plus this, plus this, plus that. Okay, so that would be 8. And 2 is 10. 10 and 1 is 11. And then, so that would be 11. And then I have 2/5 plus 2/5 is 4/5. 4/5 plus 1/3. Okay, so my next question is, what is 4/5 plus 1/3? Well, in order to add, we need them to be of the same size. So I am thinking these common multiples, right? So 3, 9, 12, 15, 18, 21, and so on. And then we have 5. Oopsie, I'm not sure what just happened. We have 5. So then for 5, multiples of 5, we have, 5, 10, 15, 20, 25, and so on. So common multiple is 15. So we're going to think of these fractions as 15, meaning cut these little pieces into smaller size. And you notice that I didn't draw pictures because we have just already reviewed that before. So this would be If we need to go up to 15, the concept really is to multiplying by 1 to get a common denominator, because when you multiply by 1, you are not changing the value of the fraction, just the way it looks. So to get from 5 to 15, I am multiplying by 3. So we are really multiplying by 3 over 3, which is 1. And so this would be 12. Similarly, we are going to multiply 1/3 by 1 to get a common denominator. And this one in this case is 5 over 5, and that would be 5/15. So altogether, we have 17/15 plus the 11, right? And 17/15 is 1 and 2/15. So altogether, we have 12 and 2/15. And that is our answer to this problem, 12 and 2/15. It's just a little bit more complicated, a little bit more work with mixed numbers, but the concept is there. Use the area model, figure out the answer to each one's smaller sub-rectangles, and then add them together. And that is that for multiplication.